How close do you think we are, in your view, to truly autonomous AI systems that can plan and execute complex workflows?
Honestly, I think that our work is the only pathway that I see there. And based on that, I'm going to say a year.
Jacob, coffee, tea, or something else? What fuels your mornings?
None of the above, honestly. Usually
Oh,
bone broth, if anything. Yeah,
interesting.
I'm opposed to caffeine, not morally or anything.
Yeah.
Just don't
How long have
believe it.
you how long have you done the bone broth thing?
Year or so.
Yeah. Did you notice any like real health or mental benefits?
I don't think so. It's just a nice way to start the morning. I've just not got a lot of things that I want to ingest when I first
Yeah.
wake up, and the bone broth it's good, probably like collagen or something, but it's more
Yeah.
just like it's very digestible.
I like that. I like that. Yeah.
Also, I just feel like you want to be sipping something hot out of a cup. You know that
Yeah.
I still have the desire to sip something hot out of a cup,
Just
even though
not
I don't
caffeine.
like the caffeine. Exactly.
Makes sense. No, that's good. When you were a kid, what did you think you'd grow up to be?
Scientist. I actually
Yeah.
recently was sent a picture of like a second grade yearbook or something with quotes from one of my friends, like with all the people in the class saying what they wanted to be when they would grow up, and it was
And yours
scientist.
was that. That's so wild. Okay.
Yeah, I
Very
pulled it
cool.
off.
Yeah, yeah. What drew you to that? Was it just like interest in science in general? Was it a family thing?
Yeah, I think just interest in science in general, a desire to, yeah, argue. Probably those two things.
Like that. What's one technology that you can't live without?
The books count? The printing press? I'm gonna go with
Yeah.
printing press. I feel like I
Cool.
could live without the other stuff. Maybe air conditioning.
Egg. Oh yeah. Yeah, that's true. Where do you live?
New York. So I
New
could easily
York.
live
Yeah.
without air conditioning. It's not like I would die, but I enjoy it.
Those summers are brutal though. They are. And if you can fast forward 10 years, what would you want or looking at the impact that your work's had, what would you want that to be?
Just be an important milestone in the field. Something that is answering an important question, making an important insight, and allows everyone else's work to be propelled forward as a result. Just an important milestone on the path.
Awesome. Awesome. All right. Welcome to Machine Minds, everyone. I'm your host, Greg Terusian, founder of Samson Rose, your robotics talent search partner. And on today's episode, I'm joined by Jacob Buckman, co-founder and CEO of Manifest AI. Thanks for being on the show today, Jacob.
Thanks for having me, Greg. Excited to get started.
Yeah, my pleasure. Let's jump into it. So let's actually start with your journey and what led you into the world of AI and ultimately founding Manifest AI.
The journey into the field of AI is honestly so long ago that I barely remember it. I've always been really into science fiction, just excited about the ideas in the space. Read a lot of Isaac Asimov, as a kid, and pretty early on started coding, started using writing programs that were intelligent in various ways, and always just thought one of the most fun things is writing code that does work for me. Right? It's something where I get to take credit for it. You just set it up at the beginning, and then after that, everything just follows, and you get credit for all of it. Which I always
Yeah.
just thought that way of doing things was so cool. And in college, I went to Carnegie Mellon, where there's a big AI interest and a lot of people working on just very cool things, and ended up working as just undergrad research with some professors who were like into the idea of AI, deep learning specifically, which at the time was not as ubiquitous as now, but definitely like a burgeoning wave. I think a lot of people were very excited about it at that time.
Yeah.
And I basically fell in love and have not worked on anything else since for the entire rest of my life. And was at Google Brain for a bit. I was doing a PhD. The desire to start Manifest specifically came mostly out of just a sort of a high level vision for where the field was going, sort of seeing the potential of the current technology, seeing where it could lead, the power of scale and the power of harnessing sort of like internet scale data for intelligence, and asking the question, okay, is this it? Right? I think even in like 2021, 2022, the writing started to be on the wall for a lot of people as far as, yeah, we're going to be able to like approximate human level intelligence using this framework at scale. But the question is this all we need? Is there going to be something more? And after sort of thinking about, from a technical level, the different pieces of the puzzle, my co-founder and I, argued about it for many years, refining our opinions, our takes, and came to the conclusion that there was at least one crucial technical piece missing between what we have now and what the future of AI will inevitably, in some sense, hold. And we founded Manifest AI essentially to make that breakthrough, fill in that final missing piece, and bring the field on to the sort of next generation of the technology, unlock the next paradigm towards intelligence.
Awesome. Awesome. Well, I mean, with all of that, I kind of want to jump ahead and just go straight into Manifest, because I wanted to understand a bit more of your research background and how all of that, being a Google brain and everything like that, kind of shaped and influenced your perspective and what you wanted to bring to the world with Manifest. So, and obviously you worked on some interesting projects in the AI ecosystem and things like that. But for listeners, we will jump back into that because I think it's super important. But for listeners who might be hearing about Manifest AI for the first time, what's the core mission of the company, or what is it that you guys are really trying to do?
We have a vision for what it would look like to have an AGI. Basically, what the set of capabilities that are theoretically possible with the technology that are not yet implemented or implementable with the current paradigm. And specifically, the place where we feel that the current stack falls most short is on essentially input size scaling. So when you're training these models, you need to basically show them an input, some amount of information, which they then synthesize in order to make a prediction. And the process of making that prediction is encoded in the weights. But ultimately, part of making good predictions is having a very rich input, synthesizing a lot of information all at once to produce your prediction, your decision, whatever the outcome would be. And this is a place where the current sort of paradigm, large-scale transformers specifically trained with great descent, just falls short. All the other axes of scale were good. We figured out how to scale parameters, how to scale data sets, but the individual inputs being shown to these neural networks are almost pathetically tiny. You'll have literally a 600 billion parameter neural network being trained to process inputs that are a couple of kilobytes of text, which is just literally 6 orders of magnitude apart in how much effort we're spending on getting the weights right versus getting the input right. And this is what Manifest is aiming to crack, basically to understand what is the correct technological stack. It's not transformers. What are the pieces that we need in order to actually train and then eventually do inference at a tractable cost on massive, massive inputs?
That's, yeah, hugely interesting, but also hugely impactful. Your focus right now is building real world AI systems and AGI, or basically enabling that to happen, as you mentioned.
Enabling,
so
exactly.
Yeah, what specific technologies are you trying to develop right now? What problems are you trying to solve right now to enable that? If we're moving away from transformers, is it a whole new way of working, or is it, new actual option instead of transformers?
Yeah, I think ultimately there'll be multiple pieces to the puzzle. At Manifest, we're engaged in various research directions, but the one that I'm most excited about and has had the most impact so far is on the architecture side, essentially replacing transformers with a new family of architectures, which we call retention architectures, power retention specifically, that unify the benefits of transformers with the best parts of recurrent neural networks, or RNNs, which are the architecture that preceded transformers. And RNNs were great at processing very large inputs, but they had one major and in fact fatal flaw, which is they weren't very smart. And transformers now, they are essentially the equivalent of a human with photographic memory. You're able to memorize every single piece of the input and use all of it, truly use all of it to produce a response. But ultimately, humans don't have photographic memory for a reason, right? It wouldn't make any sense for your doctor, to have to replay every single one of his years of medical school just to give you, oh, you've got a cold, right? No, that's just not a question that requires replaying your entire life's history in order to answer. And with transformers, that's essentially what they do. And this is why transformers are capable of solving lots of really important but ultimately very brief, narrow questions. They sort of have, in some sense, a very short lifespan of experience. And so tasks that require, not just like a brief, like a direct response, but iterative refinement, laboring over a problem for hours, days, weeks at a time, transformer-based models are simply not capable of solving. And this is a prediction that we made, several years ago, that we wouldn't see these capabilities emerge. And in spite of lots of exciting developments in the field over the last couple of years, we still, we were vindicated in our predictions that these technologies are just not equipped to handle these sorts of tasks. And we're basically looking to replace what we view as the key bottleneck preventing transformers from accomplishing these tasks, which is the attention layer, which attention is sort of the heart of transformers. And that's what makes a transformer, is the attention layer, right? Because attention is all you need. That was the name of the first paper that introduced it. And that's the key way that transformers differed from architectures that came before them. Now, modern transformers are not the exact same as the transformers proposed in that paper. They've had a lot of different tweaks, but that one piece, the attention layer, has remained constant and present through all of these iterations. And it's, carry us a long way, but it's time for it to go. The next generation of the technology is going to require replacing attention with our architecture, power retention instead.
Power retention, awesome. So can you walk us through more of that, the technology, how it actually works in practice, and how it's going to enable this next wave of the technology?
Yeah, absolutely. The key insight is just around how the memory is being stored. As I mentioned, the memory of a transformer is like a photographic memory. The actual update operation that transformers do as they see more and more tokens of context is basically append. You've got a list of things that you've seen so far. When you see one more thing, you append it to that list. And whenever a transformer makes a prediction, it has to reread through everything in its list to choose what to attend to. So it stores everything and just attends to some of it before making a prediction. Our architecture, retention, functions differently. It only retains the relevant information, the information that it thinks it will need in the future. So in some sense, for retention, the update operation is not append, it's compress. Whenever you see a new piece of information, you're modifying your beliefs to incorporate that new piece of information. And the size, in some sense, of your memory is not growing. It's a fixed size. But the quality of your beliefs is improving with each new piece of information you see. And this is what makes it actually tractable to scale to massive inputs or to have models that can persist an individual session over many, many days. It's because you're not actually paying increasing costs the more you remember. You're only getting higher quality predictions as a result of that new information.
Wow. Okay. And I know you started this by saying this is going to obviously enable like AGI, right? But, and correct me if I'm wrong, it sounds like when you're explaining it that this would be super beneficial to a very deep but specific subject initially anyway, because as you're learning or feeding more into the model, it's going to be refining and improving its memory, its understanding of whether it's a topic or a day or a project, whatever it is. But how does that work if you're trying to do something super general purpose or AGI? Like, does that work well in that situation right now?
In some sense, this ability to update your beliefs as you learn more is that general reasoning faculty that you're looking for. It's what enables a single model, a single agent, a single set of weights to be able to be a salesperson or a software engineer or a pharmacist, because you just show them, here are all the educational materials to become a competent salesperson. here are a couple practice rounds selling to different people. And now what you end up with, once all that information has been compressed into the beliefs of the model, you end up with something that is capable of being a good salesperson. Similarly, if you instead give it software engineer training and then let it practice being a software engineer for a while, now you have something that's capable of being a software engineer. Now, zooming in, this sort of happens at every depth, because an individual task executed by that software engineer can be viewed as an iterative procedure of learning more and more about the problem at hand. You're reading files, learning more about the code base. You're running tests, learning more about the structure of the code that you just wrote. You're, looking at outputs, learning more about the structure of the problem setting that you're working in. Maybe you're even reading Slack messages, learning more about what your boss wants you to implement that day, right?
Yeah.
So this is the same learning procedure that took you from blank slate or limited initial knowledge into being a software engineering specialist. Also takes you from being a blank slate software engineer into a this problem that I'm solving today specialist. And it's this flexibility, this dynamism that we really feel is going to be basically an absolutely necessary component of anything that we could consider a truly general intelligence.
Very cool. Very cool. So jumping back, obviously you had a career before starting the company. Were there any lessons that you learned or early experiences that shaped like your perspective on building these kinds of systems, or that made the problem like glaringly obvious to you and kind of empowering this prediction that you guys had?
I think something that was extremely valuable to me was being able to see how all the different subfields of AI gradually became unified under deep learning. It's something that really taught me the power of simplicity, of scale, of elegance. Rich Sutton calls it the bitter lesson in a very famous essay, which is that if you set things up such that performance improves with compute, you will eventually beat any hand optimized algorithm as a result of compute growing and growing and growing year after year. And initially, when I started working in AI, it was much more fragmented than it is today. People say AI now, and you know what they mean. You mean deep learning, large language models, a very, in some sense, narrow set of techniques in the space of all possible techniques that can be considered. It used to be the case that AI was a big umbrella, and in that umbrella, some people would do sort of like tabular or sort of like classical machine learning, logistic regressions, linear regressions, things closer to statistics, support vector machines. Then there was another subset which people would call computer vision. And these people used hand-engineered edge detectors and filters and various techniques on top of that. There was another specialty, natural language processing, speech processing, right? Each of these things had their own specialty, their own algorithms, their own community, and their own experts. Now, obviously, there was still some communication between these fields. They're not like they were entirely unrelated. But what happened is, when people realized how powerful deep learning was, suddenly every one of these previously disparate subfields started to taste a lot like applied deep learning, And you start to realize, actually, there's just a few important principles here, a few key ideas. And if you want to maximize your performance in any domain, nowadays we would just refer to it as modalities, right? Like a particular model might have text, image, and audio as its input modalities, and a text, image, audio as its output modalities. But those used to be completely different subfields with their own algorithms, right? And it's this gradual unification and realization that, no, just a few key ideas plus scale allows you to process data from any modality. So actually, the data is, in some sense, indistinguishable from each other. And it's the unified processing that's important. Scale that up, and you've solved everything. And I think that definitely affected, to a very large extent, how I view research now. We're constantly trying to break things down to first principles and unify them. People will draw some distinction, like one that, this is a bit old, but people will say like generative modeling versus discriminative modeling. This is something that for many, many years, people really emphasized this difference. There are two types. And you just think through it a little more, you realize, no, these are actually like completely unified. There is no line that can be drawn, no meaningful distinction between generative modeling and discriminative modeling. It's just modeling. It's all just one thing. And with that realization, a lot of research directions start to scratch your head, right? It's like, what are you doing here if you can just do it this other way and have it work just as well? So that's like one specific example, but these sorts of trends appear everywhere and is very much how we at Manifest think about the space. Always rethinking from first principles. What are the right abstractions to be using? What is the simplest way this can be posed? Is this a method that is going to scale, or is this a like ad hoc hack, something that is only going to work in the short term but ultimately fail to deliver value? And it's that sort of thinking that really clarifies where things are potentially extremely high impact. And in this case, it's just this realization that there's one axis of scale that, unlike all the other axes of scale, is really expensive to scale. And realizing that, yeah, that's where we're going to have to intervene if we want to reach the outcomes that we're looking for.
Yeah. Yeah, you hear about the topic of cost, right? So much these days, whether it's the data centers, energy, even just like monthly user access to some of these higher level programs and things like that. So there's two schools of thought, right? We saw what like DeepSeek did with their model that came out and all of that stuff. So I think that is really what's going to drive this next real utilization, adoption, but scale and commercial viability as we try and do more. And everyone needs to use it, and in every industry and in every modality or whatever it is. If we can't, then it's just going to hit a very large roadblock that is going to, I want to say tank the industry, but we're going to see like a lot. There's so much money flying into it right now, you know, and whether it's a bubble or it's like people that aren't sophisticated investors or asking the right questions or whatever it is, you know, I'm not qualified to say, but hearing about things like you are building makes you realize like it will hit that point sooner, probably rather than later, with the rate of adoption, the rate of technological advancements, that it needs to be fixed.
Yeah, I think that this sort of research is inevitably going to be required. Ultimately, I think focusing on absolute costs can be misleading sometimes. What you're really looking for is cost per sort of unit of intelligence. One of the biggest breakthroughs in the field was this discovery of scaling laws. This idea that we could essentially directly, in a predictable, measurable way, turn dollars into intelligence. Dollars buy you GPUs, GPUs run training gives you a model, inference on the model gives you intelligence. But that pipeline, every piece is robust, and some pieces are very, very expensive. But ultimately, it's not a question of like, how much money are we going to spend on this? Intelligence is the cornerstone of the modern economy. People are willing to spend for intelligence. The question is just, is it a good price? Right? Are we getting it cheaper than we could get it elsewhere? And right now, I agree with you. I think you're not necessarily getting a lot of it at a good price. I do think that if we restricted to just the highest value use cases of even the current models, and we lopped off their ability to do everything like complex, difficult, and expensive, then what remained would actually still be hugely economically valuable, right? However, people aren't satisfied with that. They want to push beyond and push the limits of intelligence. And this is where people are making essentially speculative investments, trying to say, okay, if we pour more money into this, where will it lead? And even if it doesn't pay off immediately, the hope is that somewhere at that frontier of intelligence, there will be something where that trade-off makes sense. And the way I view our work is as improving that ratio. We're making things cheaper, yes, but that doesn't mean that they'll be spending less overall on them. They'll be spending the same amount and getting more bang for their buck, thus translating into a more economically useful final product. But don't expect the top line costs to go down. People will still be pouring as much money as they reasonably can into this technology just because it's so exciting and the potential impact is so high.
Yeah, that's true. I guess if the quality is improved, if the product is much better and it's premium, then it justifies the cost, right? It's hard to do it the other way, instead of it just being a gimmick of, oh, cool, I made this new video that I didn't have to touch it a little bit. there's still errors and what you're actually going to do with that. But if you're using it for something like commercially viable, the cost definitely makes sense. What, I don't know if you could share any of this, but what have been some of the biggest like technical or strategic challenges that you guys have faced so far?
Yeah, I mean, we're completely open source at this point, so nothing hidden. Happy to share. I think
Awesome.
probably the biggest technical challenge that we've had to tackle has been around the low-level code executing on the GPUs to run our new architecture. I think there's a lot of researchers who are very comfortable in the more theoretical or like abstract domain. They're still running experiments, but they're running experiments to get curves, loss curves, performance curves. They just want to show that their line is higher than the other line, and then they wash their hands and call it a day. And for us, that's not enough. We're not interested in making a new architecture so that we can draw a line that goes above another line. We are still drawing those lines, of course, but we're doing it as a stepping stone with the ultimate goal of genuinely training the most intelligent models on the planet in various domains. And that means that it's not enough that our model is theoretically faster than a different model, that it uses less flops, right? What we actually need is wall clock time. We need this model to run faster than anyone else's model can. And that means translating our architectural insights into actual like CUDA kernels, for example, for NVIDIA hardware, in order to be able to run them very quickly. And because our architectural innovation is leveraging some basically some interesting math, some interesting properties in order to actually deliver the performance that we expect out of it, that translates into a very technically complex implementation on GPU hardware. The sort of naive way that one might think to implement our architecture is not well suited for GPUs, and you basically can't do a good implementation of it. There's some high-level frameworks, something like Triton or Palace, that are basically designed to make it easy to implement GPU kernels via a more Pythonic interface. And while the first versions of our kernels were written in this, we're still leaving like 4x, 8x performance on the table, simply because those intermediate libraries were not designed with our architecture in mind, and we're forced to use features of the kernel, features of the GPU that the Triton kernels simply are not designed to be able to leverage. And this meant we had to embark on essentially a 6-month endeavor to really squeeze the performance out of the hardware. And we ended up, an outcome of this, not only did we have very fast kernels for our architecture, we actually, in order to get there, needed to write an entire framework for writing clean, testable, performant GPU kernels. And we call it Vidrial. And then, just for fun, we re-implemented flash attention, which everyone else is using, in Vidrial, and wound up with something that was 20 to 30% faster than the open source implementation of flash attention on lots of problem shapes. And so basically like the level of technical depth that had to go into designing Vidrial in the first place was sufficient to basically produce this result as a side effect. So that was definitely one of the biggest challenges we had to face. It took us quite a long time to get here, but now we have something that is, you can pip install retention and plug and play into any old transformer, and you'll immediately see like the speed will massively increase on long contexts.
That's really cool. So who's using or who can use, put your technology or architecture into their world right now?
Anyone who's using open source models is able to easily swap in our retention layer in place of the attention layer that they're currently using. I think something that we are really excited about, we haven't, completely put this release together yet. It's upcoming, but we're looking to basically put together a toolkit for people who want to transform existing open source models, for example, the Llama family of models or the Qwen family of models, and transform them into their power retention based equivalents. And it's actually extremely cheap and easy to do this. It requires a couple hundred steps of, we call it retraining, where you start off with a transformer model. In the model architecture, you swap in retention instead of attention. And then you just train on the data set that the model was originally trained on, or a similar data set, for a couple hundred steps. And what you end up with is a model that has retention as its backbone instead of attention, but has equivalent performance, or very nearly equivalent performance, to the original model. And from here, you can do very, very fast long context inference. You can do fast long context like fine tuning or additional training on your own custom data set, any of these things. We've so far released one model like this. We call it Power Coder. It's sort of retraining of a model released called Star Coder. And so that's sort of like our initial proof of concept. But now we're working on releasing a whole family of even larger and more performant models that we've done this retraining to, as well as a toolkit by which anybody can effectively do this retraining.
Very cool. Okay. How did you go about approaching or even building the founding team, and how did you all get connected?
Cutlass and I have been Cutlass and I have been doing research in complementary areas for a very long time. And so he was a completely natural choice for co-founder. We've been collaborating on basically everything that either of us have been working on for probably close to a decade now. There's basically no one else who I've been as productive with on the research side of things in my life. And so, of course, if I'm going to start something, we're going to start it together.
Natural choice.
And beyond here, we're basically looking for people who are also capable of sort of the same core pillars of research, very strong mathematically, very strong engineering skills, very strong scientifically, and then just good background in deep learning. Somebody who has all of these four pillars is somebody who is able to sort of like communicate with us effectively, participate in all sort of pieces of the project. So that's sort of the ground level requirements. And then beyond there, we're really just looking for people who can bring some skill to the table that we are missing, somebody who can just like vastly exceed us in one of these areas. Sean, who is our founding engineer, is an absolute machine, especially on the CUDA side of things. I've just never seen somebody with like faster, more reliable ability to just like engineer something and deliver it. And he's also got like 5+ years of CUDA experience. We couldn't have written the Visual package without him. So basically that's what we're after.
Nice. So it sounds like across the board multipliers, really. Someone that's going to come in, like multiply everything you guys have done, but then also their own specific vertical output as well.
Yes,
crucial.
Exactly.
Yeah, crucial at the early stage. So you guys recently caught attention of some pretty impressive investors. What do you think? Because what you're doing, if you're not in the space or understand the use case, can be maybe harder to get their head around, like the need and stuff like that. You have to be forward looking or understand some of the limitations. But what do you think really resonated most about your approach with these investors?
I think people can understand, even if they're not necessarily fully immersed in the technical details, they can understand the broad strokes. I think it has also helped, of course, that we've been able to see what was coming several years out and been vindicated in those predictions. Also, I think it is currently still the case that lots of the large labs are sort of, in response to customer demand, trying to push their own context length. And that sort of makes it obvious that our technology, which is the one architecture capable of truly pushing context lengths, is going to be valuable and instrumental going forward.
Nice. So we're seeing an explosion of interest around AI agents, orchestration platforms, etc. How do you see the landscape evolving over the next sort of, let's say, 3-5 years?
Honestly, I think that the orchestration layer is not going to be around too much longer. I view the orchestration layer as essentially a band-aid solution for the limitations that I was describing to you earlier around AIs that are unable to truly accomplish long-term goals, which is, as I was describing, a flaw in their architecture and their fundamental design. I think the next best thing to an agent that can work for 2 days, if all you have is an agent that can work for 20 minutes, well, you have it work for 20 minutes, then write down some notes about what it did and hand it off to another agent who's going to work for the next 20 minutes. And you train enough of these agents together and you have something roughly approximating an agent that was working for 2 days, but nowhere near as good. And I think it will never be anywhere near as good based purely on orchestration. What I'm interested in is true end-to-end agents, a single agent with a unified neural memory that can continue working across this whole time span. And once you have this, the need for orchestration drops way, way down. Now, I think there might become new niches for orchestration. For example, even if you have an agent of the sort that I'm describing, let's say this is a purchaser agent who is making like cold emails, browsing websites, etc., to try to find the best, say, GPU cluster to purchase. Maybe it's still valuable to have two of these agents working in parallel, right? And communicating with each other to some extent to make sure that their work doesn't overlap. But that's going to look very different from today's orchestration systems, which revolve around sort of like revolving door of starting and stopping various agents and trying to get just as much value out of each one's context as is possible. And it's sort of that framing that I view as, which in today's landscape mostly dominates, and that's going to diminish in value greatly as the underlying models get better and better.
Do you think there's still a place for that or need for that if you're trying to build a team of agents that have different tasks, that have like the deep understanding like yours do and capabilities, but then are doing different tasks across the board?
Yeah, I think this is very plausible. But ultimately, if we could take one human and make them twice as smart and make them operate twice as fast, I think that would be better than hiring two humans, right? And the reason is that these two humans have sort of a lossy and bounded communication channel between them. To the extent that the two tasks overlap, there's going to be something missing from the potential ability of each one of them to achieve their individual objectives. Now, for AI, it's not completely obvious whether or not it will be possible to just say, yeah, let's just have one thing that's twice as fast and twice as intelligent. And in that case, yes, we then might want two things, perhaps specialized and communicating with each other, perhaps even a whole team. But one key difference between humans and sort of like artificial intelligences is that artificial intelligences can be scaled essentially indefinitely, right? Every human is just going to have some maximum potential, just like cranial capacity, right? So you're limited right there. But this isn't clear that this is necessarily going to be the case for artificial intelligences. Now, I have some arguments for why it still might be. And so ultimately, I think jury's still out on this one. There's strong arguments in both directions. But I think it's very plausible that we will end up still seeing teams of agents being orchestrated together. But it's also equally plausible that we will not. And people will realize that actually once the agent itself, the underlying model, gets smart enough, then just one is what you want to go with instead of having multiple and trying to make them communicate. One is simpler,
so much more efficient, it sounds like, as well. And even from a user standpoint,
right.
I think that's a daunting part. Yeah, it's a daunting part for people who aren't really clued up on this or know how to build their own agents or anything like that. And like trying to string together a group of them to do a task is daunting. And you're just like, what? Let me not.
Just one. Just
one.
I think it's not unlikely that will happen.
Yeah, no, that makes sense. Makes a ton of sense. How close do you think we are, in your view, to truly autonomous AI systems that can plan and execute complex workflows?
Honestly, I think that our work is the only pathway that I see there. And based on that, I'm going to say a year.
A year? Wow.
Yeah.
It's crazy.
I think there's still a lot of big open questions. I think a year is maybe we'll see the first example, but I don't think that will be the final form. I think that we'll continue to see agents pushing longer and longer sort of like task completion times as the years go by.
What are some of the biggest misconceptions about building agentic systems today?
I think probably the one I view as the largest is just infusing these agentic systems with a little too much theory of mind, treating them a little too much like humans. I think it's a decent heuristic for how these systems will behave, what they will do. After all, that is what they were mostly trained to do. But I think assigning too much humanity to them is an easy way to find yourself in any number of pitfalls. An analogy I like to use here, have you seen the movie Memento?
Haven't actually. Let me note that down. It's been on my list. But...
Yeah. I mean, great movie. But essentially, it's about a man with short-term memory loss. He can only remember the past couple of minutes. And in order to sort of achieve his longer-term goals, he writes messages to himself in English, in tattoos and little Post-it notes in order to sort of stay on track and remember what he's been trying to do all along. And it doesn't go so well for him. To avoid spoilers, I'll just leave it like that. And I think ultimately viewing Memento is a great way to understand how you can expect your agents to behave as well. And I think it basically will prevent a lot of confusion of them doing things that are seemingly stupid, that you would never expect a human to do. But if you model them as the guy from Memento, now suddenly maybe it starts to make sense, why they might end up, for example, repeating the same mistake over and over again, or, describing why there is an error here. And then they go to fix it and just don't fix it. They just do other stuff, even though they just said that this was an error. These sorts of things make a little more sense when you realize that it's just basically forgotten everything that just happened and kind of trying again.
Interesting. On the note of, assigning human characteristics and stuff like that, how do you think that the relationship between humans and AI will change as, technology like yours matures and just adoption increases across the board?
One of the main dynamics that's going to change is around, in some sense, the way that humans relate to AIs. Not necessarily in an emotional sense, but right now AIs are typically viewed explicitly or implicitly as something akin to a consultant. You open up your chat window, you start a conversation, you ask a question, there's some back and forth, you're given the answer to your question, and you close the chat window, right? That's sort of the end. When you have another question, you start a new conversation. And the person the AI you chat with the first time doesn't know anything about you. The AI you chat with the second time knows barely anything about you. Sort of all it knows, maybe the first AI took some notes and stored them in a hidden system prompt so that the second question contains some amount of information from what you discussed the first time. But really it feels like talking to a second consultant, maybe a second consultant from the same company who read the notes of the first. But once you realize that this is sort of downstream of these models only being able to process short contexts of information at once, you realize that technology like ours is going to really change this paradigm. It's going to be less like a consultant that you visit once and more like a butler who is with you your whole life. Somebody who every single time you ask them for help on something doesn't just give you help on that thing, but also internalizes what problems you had, what solutions you preferred, understands your preferences, maybe learns to expect your needs before you even ask them, learns to anticipate. You go from having sort of like multiple chat windows with what feels like multiple different consultants, all powered by one AI, to one ongoing conversation with your AI. Suddenly, it actually becomes important that you log into your own account to ask this AI a question. Because if I log into your account, there's meaningfully less ability to respond to my needs. This is something that we don't actually see much of today. Like, you'd have no problem logging into my account to ask a question, unless that violates the terms of service and we both get banned from the platform. But aside from that, there'd be no issue, no downsides. But that won't always be the case. And I think this is going to be a big way in which people start to relate to AIs very differently going forward.
Interesting. Yeah, that's, I think, a goal for a lot of people that are trying to lean more and more on it. The memory, the personalization, the backstory and preferences. And I think that will definitely increase adoption as well, because right now you can, and I think increase the stickiness of the tool, because right now we have so many options, right? Whether you like ChatGPT or whatever, there's other options. But when you have one that's really going to know you, learn you, have your backstory, you're less likely to switch.
Yeah. In the same way that sort of airlines, you could see airlines as being interchangeable until you become a valued member of the rewards program. And now you're locked into this one airline. This is what you fly only.
Yeah.
We haven't seen that at all for AI agents, which, as you said, are completely interchangeable. Different chatbots, different agents. People might have some slight preferences for one or the other, but those preferences are not very strong and liable to change in an instant if a different lab puts out a slightly better model.
Yeah.
And this is no longer going to be the case in a couple of years, I believe.
Yeah, true. You can see that. So what's been your, shifting gears here slightly, I'm curious about one of your proudest moments so far as a founder. What's that been?
Honestly, my proudest moments as a founder are my proudest moments as a researcher. And it's very hard for me to disentangle these two things, given what my company is and what we aim to do. And I think there was a moment in, I guess it was around April or May of this year, where we finally put the final couple pieces together. And every experiment that we ran from that point on came out exactly as we predicted it would. There's just something about running an experiment, you run it before you go to sleep, you wake up in the morning, you look at the curves, you look at the measurements, and you go, ooh, this isn't what I expected. What could be wrong here?
Yeah.
And you iterate, you think, you try again, more the next day, and at some point, it just stopped being wrong. We would say, hey, we should probably run this experiment to check this assumption that we've made. We do, and it comes out exactly as we predicted. And I don't know if it's a single moment necessarily. It's more of a gradual retroactive realization like, hey, over the past couple months, we haven't been wrong about anything.
Yeah.
We actually have it. Like we actually have a complete picture of what's going on. And to me, that's sort of what I've always aspired to as a scientist, is to have a novel and complete understanding of a really important phenomenon. And the fact that we were able to pull it off with like a small focus team and a small amount of resources is something that I was very, very proud of.
Yeah, as you should be. Yeah, that's huge. How do you personally stay sharp and informed in such a fast moving field like AI is right now?
I think something that helps me is having my own model of the space. I'm not necessarily going to know every new technique, every new release, everything that's hot, everything that people are talking about. Maybe they'll, flit across my radar at some point. I have lots of, for all the various time I've spent in the field and all my different institutions, I have friends, we discuss. So I hear about most things, I would say. But I don't think about a lot of it. A lot of it I dismiss immediately. Because when I look at some idea or release, something like this, the first thing I'm doing is assessing, like, where does it fit into my existing model of the field, my existing framework? And if it fits into a bucket that I already feel that I don't understand or don't care about, and it's not something so exciting as to draw my attention and make me sort of like reopen that door, then that's all the time I spent on it. That's it. I think a lot of people make the mistake of being overwhelmed by sort of like the torrent of content. And it is true that there's a lot of stuff happening. And most of this stuff has real technical depth to it. And you could get sucked in for hours just understanding what's happening here. But I think a really important skill is not being sucked in, just understanding the exact level to which it is worth your time to understand this thing, being able to quickly do that, quickly internalize, and quickly, if necessary, put aside the less important insights. So I guess, another way of framing it is I'm really looking at all of it and just sifting for the insights, like a prospector sifting for gold. I'm not trying to consume the whole river. I'm just sifting out the nuggets of insight. And I think this is what makes me feel confident that I basically know all the important ideas at any given time.
I think that's crucial to be able, it's kind of like a filter, right? A filter of what's relevant, what's not, what's going to sidetrack you, what's completely wrong. And some of that comes with confidence, experience, and knowledge, right? And because early on in anyone's career, you can just get, ooh, squirrel, let me go that way. This looks interesting. Oh, let me see how I can put that into my model, my technology. And I think that's very, very important. Yeah, good point.
Yeah.
Good point.
Yeah. Focusing, something that's been very valuable for us, and honestly very difficult as well, is identifying what the piece that we think has most value is and pushing only that to the greatest degree. We're not trying to throw everything under the sun into our models, even some stuff that might be helpful. We're trying to focus on the key strength of our architecture, which is extremely powerful, long context performance. This is the best family of recurrent neural networks that has ever existed. We have trained the best RNNs that have ever been trained. And soon we're going to release the weights, and everyone will be able to use the best RNNs that they have ever used. And that's where we sit. If that is 0.1% better on some tasks because we brought in a huge amount of complexity via some arcane data pre-processing technique, it's not what we should be doing, right? Like, that's not the focus. And honestly, like, constant struggle, especially I think the researcher archetype is the sort of person who is easily, as you said, distracted by cool or interesting things that they might want to spend time on. But, we do our best to put those things aside, or at least postpone them to the appropriate time, and stay focused on what is most important.
I was going to ask for a piece of advice to founders or aspiring founders and engineers in the AI space right now. That seems like a very good piece of advice, and just like something to keep in the back of your mind. Is there anything else that springs to mind, or maybe like a book, podcast, resource that's had a big impact on you?
Honestly, I don't know. I agree. Yeah, I think that's probably what I would give. There's no particular book or podcast, unfortunately. I think that's me.
Cool. All right. Awesome. Well, look, I know we're at time right now. I just wanted to thank you so much for being on the show and taking the time to share about Manifest AI and your journey, and honestly, the hugely exciting and impactful work that you guys are doing. And I'm really excited to see it being implemented in the space. So thank you again.
Yeah, thanks so much for having me. It was a lot of fun.
Yeah, my pleasure. How can our listeners learn more about you and just follow along with Manifest AI's progress, or apply to any of the jobs that you guys are trying to fill right now?
If you visit manifestai.com, all of our open source research is available there. You can find links to our papers, to our GitHub repos. Pip install retention will give you access to our kernels. And you can also find links to follow along with future releases. Subscribe to our mailing list. We have a community Discord, and we're basically going to continue to release architectures, kernels, models, and just push the ecosystem of large-scale, long-context modeling forward. So if any of that stuff sounds exciting to you, or you have a cool long-context data set that you want to work with us to train on, or you're interested in working more closely with us, we are also hiring. So that information is also all available on our website. So please, check it out. Send me an email. Let me know.
Sounds good. All right. Thanks, Jacob. I will keep in touch with you, be following along and supporting from the sidelines. And I hope to speak to you again on the show.
Appreciate it. Yeah, looking forward.
Take care.